Hey, so this is a randomized 3D maze generator that I built using Unity 5 3D. It uses sort of a modified version of Prim's algorithm for minimum spanning trees. I had to change it up a little bit just so it fits within the context of this project, but the idea is mostly the same. So it generates a cube that you choose the proportions of and then builds a random maze within it. So it can do anywhere between 2 by 2 by 2 mazes all the way up to 10 by 10 by 10 mazes. And it's different every time you generate one. So say if you wanted a bunch of 4 by 4 by 4 mazes, you could just keep resetting, and you can see that the layout is different every time. It always has the entrance somewhere on the front side, and then there's an exit somewhere on the back side, right at the top left over there. You technically could put the entrance and exit anywhere or randomly, but I just wanted to make sure that there was some sort of minimum distance between the entrance and the exit. So that's why I put the entrance on the front side and the exit on the back side. But you could do it anywhere. And there's always a path between them. It's easy enough to solve with the 2 by 2 by 2 mazes. As you can see, 3 by 3 by 3 should also be fairly simple to solve. There's only so many spots it could be. Let's see. No. Is it down here? No. There it is. Alright. So the way it actually works is that it initially creates a wall in every single possible spot, and the maze is technically broken up into a bunch of different nodes and a bunch of different walls. So a node is just a 1 by 1 by 1 space somewhere within the maze, and it has references to the walls that surround it. And a wall is just exactly what you'd think it is. It's just one of these red walls, but it also has references to the 2 nodes that it separates. So it designates a random starting point. There's walls everywhere, and we have a list of discovered nodes and a list of discovered walls. So we discover this node, and we also discover all the walls that surround it. And so much like Prim's algorithm, we'll choose a random wall somewhere in the list of discovered walls, and we just have to decide whether we want to delete it or whether we want to keep it for the final maze. So if that wall separates a discovered node from an undiscovered node, then, well, one, we know that we've discovered a new node, so we want to delete that wall. So it basically allows a passage from a discovered node into the newly discovered node. And with that new node, we mark it as discovered, and we find all the walls around it and mark any of the new walls that we found as discovered as well. But if we choose a random wall and it separates a discovered node from another discovered node, we know that there's already a path from those 2 nodes somewhere, so we don't delete it. We remove it from the list of discovered nodes, or from the discovered walls, but we don't delete it, so it's a wall in the final maze. And we go through all of that, and we just keep discovering things, again, much like Prim's algorithm. And the final product is something like this, where we have a 3-dimensional maze. The only other thing you have to keep in mind is you have to determine the exit. For the exit, I just took the last discovered node on the back wall and then deleted its back wall. So based on the algorithm, we know that there is some path from the entrance to the exit, and thus the final product is a randomly generated 3D maze. So this is actually just a modified version of the code that helps visualize how it works a little bit better. As you can see, it starts with walls in every single spot, and it'll slowly go through the maze and discover these walls and then delete them as needed. and create the passages to the new nodes. So it starts from the entrance and then it branches out, as you can see. So if we go on this side, you can see none of these nodes or walls have been discovered, so they haven't been deleted yet. It waits a second before it determines the next wall, so this is going to take forever for the 10 by 10 by 10 maze, but once it goes through all the walls and determines whether it wants to delete it or keep it, then it'll take the last node on the back wall and then just delete its exit. So that about wraps it up. I hope you enjoyed the video, and I'll see you later.